Today we're gonna work on this worksheet number 10, the last worksheet, I believe. And we have four problems here. And let's go over them one by one. The first problem, go below max and min search. Question A, the sum of two non-negative numbers x and y is 16, which what is the smallest possible value of x squared plus y squared. So what we know here is that x plus y is equal to 16, right? And these two numbers, they're both non-negative, right? Non-negative. So it implies that the range of x can be as small as 0, right? And it can be as big as 16 here, right? Non-negative. Okay, and our target function is x squared plus y squared. So to find its max or min value, we need to use just one single variable to express this function. So I will use x to express y, right? Here we can also express y in terms of x. So y is equal to 16 minus x. And then we substitute this into this expression here. So now this x squared plus y squared is equal to 16 minus x bracket square. And now we can simplify this, right? This is equal to x squared plus, that's 16 squared plus x squared minus 32x, which is 2x squared minus 32x plus 256. Okay, so this is our f of x. Okay, and then to find the max and min value, we need to consider its derivative. So find the derivative. That is 4x minus 32, right? And now we let the derivative equal to 0. So we have 4x minus 32 equal to 0. And that is obviously x equal to 8, right? So this is the critical number, right? And since we're working on this closed interval, we just need to plug in the critical number as well as the endpoints into the target function to test the function value to see which one is the max and which one is the min. So now we test this one, f0, right? Plug in 0, you have 256, right? And you plug in the other endpoint, 16 here, and that gives you also 256, right? And you plug in this critical number here, f8, that gives you 128, and therefore now we see that the smallest possible value of x squared plus y squared, it's 128. That is when x equal to y equal to 8. Okay, very simple. And after this, we're gonna move on to question B. Question B here, find two numbers x and y whose difference is 100 and whose product is as small as possible. Okay, so now the condition we have is that x minus y is equal to 100. That's the difference. And now from here we can deduce that y is equal to, or maybe express x in terms of y. X is equal to y plus 100, right? And And also there's no restriction for x, right? So no restriction. For x. So we also have x is from negative infinity to positive infinity. Or maybe we say y, because later on we're going to use y to express x, right? So that is the range. And now our target function is g of y equal to, this is going to be the product, right? So it's x times y. And since we have expressed x in terms of y, so we're going to plug in this into x. So now we have y plus 100 times y, which is y squared plus 100y. Okay, so that is our target function. And also we know the range is from negative infinity to positive infinity, right? And to consider is max and min, we need to take the derivative, which is equal to 2y plus 100, right? And then we'll let derivative equal to 0, and we have 2y plus 100 equal to 0, which tells us that y is equal to negative 50. So this is the critical number, okay? And since we are working on this interval, right? So it has negative infinity and positive infinity as their endpoints. So we just need to consider the second derivative, right? The second derivative test here, g 2 prime y, that is equal to, well, that is equal to 2, right? And so it implies that this second derivative at this point, negative 50, right, is equal to 2, right? So it tells you that y equal to negative 50, it's a local min. Okay, so we say a local min, then that gives you the smallest value, the smallest possible value. Okay, so now I'll complete this question. Therefore, the two numbers are y equal to negative 50 and x is equal to y plus 100 positive 50. Okay, these are the two numbers whose product it's the smallest possible. Okay, so that is question A and question B. They're very similar. And now maybe let's move on to the next one. Question 2. Question 2 here, we have a bus company that will charter a bus that holds 50 people to a group of 35 or more, right? So it's basically like the more people you have, the cheaper the price is, right? And if the group has exactly 35 people, then each person will pay $60 for their ticket. So if the group is larger than 35 people, you get some discount. And the discounted price is the original price 60 minus the number of people in excess of 35. So for example, you have 36 people, then you will have $1 reduced. If you have 37 people, then you have $2 down. So it's like that. And then we're gonna see how we can minimize the price here. minimize or maximize the price, or maximize the price, but it doesn't matter. Let's figure this out. Now, what are the possible value of x? So the possible value of x, it's from 35 to 50, because 50 is the largest possible value of the number in the group, okay, and 35 is the least, so it's between 35 and 50. That's also the domain of this function. And question B, what is each person's price, right? So as I said, the price will be the original price 60 minus the number of people in excess of 35, so it's 35 minus x minus 35. Okay, so that gives you 60 minus x plus 35, which is 95 minus x. That is each person's price, 95 minus x. And question C, what is the bus company's revenue? We know the revenue function, R of x, is equal to the number of people times each person's price. And we have supposed that a group has x people here, right? So it's going to be x times each person's price, 95 minus x. Very simple, like that. And question D, determine the value of x for which the bus company's revenue is maximized. So basically we're gonna take the derivative and figure out the max or min value, just like the previous question, right? And now we take the derivative, r prime x. We have, firstly, let's simplify this function first. That is negative x squared plus 95x. So we have negative 2x plus 95, right? And now we let this r prime x equal to 0. And we have negative 2x plus 95 equal to 0, which tells us that x is equal to 47.5. So this is the critical number. Okay. And now we're gonna plug in the endpoints. Right? Endpoints are here. And also the critical numbers to use the closed interval method to find out the max or min, right? So now we have R 35, right? Plug in 35 to this original function, and then you will have 2100, right? And you plug in the 47.5 into the function. That gives you 2256.25, and also plug in the other endpoint 50. That gives you 2250. Okay, so these are the three values here. And now we compare these values and see that the max value occurs at here, right? And the min value occurs at the place 35, but we're not concerned about the minimum value. We were concerning maximizing the revenue. So we have 47.5, right? Okay, so conclusion is that thus the global max of R of x is $2256.25, right? When x is equal to 47.5. Okay. However, there's a problem, because 47.5 is a decimal number and it represents the number of people, right? And we know that we can't just cut a person in half. We can't have exactly 47.5 people. We have to have either 47 people or 48 people. It can't be 47.5. So a little adjustment should be made here. However, we want what? An integer answer. Okay, so we're gonna state the following. Notice that r of x is increasing on 35, 47.5, and decreasing on 47.5 to 50, right? And here we have r 47, plug in, that gives you 2250, right? And also plug in the 48, that also gives you the same number, right? And therefore we compare these two numbers, which are the closest to the point 47.5, and then we see that these two numbers are the same, right? So now we can say that the revenue is maximized when the group has 47 or 48 people. Okay, like that. If you're wondering why the function is increasing on here and decreasing on here, you just need to draw the number line and see that the derivative is positive at this range and negative on this range. But that wasn't very necessary, because basically we know that the local max occurs at a place x equal to 47.5, and since we can't just have a decimal number, so we either pick 47 and 40 or 48, so we basically just test the function value at these 2 points and then compare them to see which one is the biggest, and then we choose that value. And since they're the same, it does not matter whether we have 47 people or 48 people, right? So the idea is just like that, and we state this just for completeness. Okay, so that is our question 2 about the revenue of a bus company. You see that it's the same thing by using the derivative and then plug in the critical number to the target function, and as well as the endpoints, right, to test those max and min values. Okay, so now should be clear for this question, and we will move on to the next one. That is problem 3. We have a box with a square base and an open top that must contain volume of 32,000 cubic centimeter. Okay, so it's here, volume is fixed, right? Find the dimension of the box that minimize the amount of material used. So let's draw a diagram first. A box like that. Right, and there's a open top, right? So it does not have this top, this face here. Here it does not have this one. And then basically the amount of material used for the 4 sides here, 1, 2, 3, 4 sides, as well as the base, right? So you're gonna compute the area of 4 sides as well as the base. Okay, so let's say that the length of the base is x, right? Since it's square base, so x is also here, and the height we use the letter y to represent it. And now what do we have? We have that the volume is equal to 32,000, right? We know that volume is equal to the area of the base times height, right? So that is x squared, right? X squared is area of the base. Okay, y is the height. So area of the base times the height, that gives you the volume. Volume is 32,000, right, here. And from here we can solve for y. Y is equal to 32,000 divided by x squared. And later on we will use this to substitute into the target function so that we can write the target function in terms of only x. So as I said, the surface area adds the area of the base, right, plus 4 sides. 4 sides is 4xy. So plus 4xy here. That is the target function, right? Let's say f of x. And we're gonna use this substitute into this function so that we only have one variable. So x squared plus 4x times this 32, there's x squared, right? So now the target function is written as x squared plus 128,000 divided by x squared. Right? And we need to know the range of this x. We know that this is from 0 to positive infinity. Because only the volume of this box is fixed, right? The dimension is not fixed, so you can build this box as flat as you want. So it could be, for example, a very large flat box like that, right? It's very short like this, right? So x will be very large at this case, or it could be very, very skinny and tall box like that, right? Skinny and tall, for example, like this, right? Very skinny box like that. That is also possible, right? X. So x can be as small as 0, right? As long as it's not completely 0, it could be a very, very small positive number, or it could be a very, very large number. So the range or the domain of this function, you can see that is from 0 to positive infinity. Okay, so we're gonna find the max or main value of this function. So now let's derive this function. Find its derivative f prime of x, that's equal to 2x minus 12800 divided by x squared. And sorry, I made a mistake here. Here should be x instead of x squared, because this square cancel with this x here. Okay, just a little bit typo. Okay, so after having this derivative, and by the way, the derivative of this is obtained by the power rule, right? Just denote it here. This one can be written as 128,000 times x to the negative 1. And you drag this negative 1 to the front, and the new power is negative 1 minus 1. So that's why we have negative 2. Negative 2, so this is x squared in the bottom here. And now we let the derivative equal to 0. So we have 2x minus 128 squared equal to 0, right? And we solve for x. Firstly, we multiply both by x squared, whole square here, x squared here. And then we get rid of the denominator, so we have 2x3 minus 128, 0, 0 equal to 0. And then we divide both sides by 2, right? So this becomes x3, this becomes 64, right? And then we move the 64, this thing, to the other side, and then take the cube root. You can use a calculator, and that tells you x is equal to 40. Okay, critical number. And since the interval that we're working on is from 0 to positive infinity, and we only have one critical number, so we consider that the limit of the function at both ends. So limit x approaches 0 plus f of x is equal to limit x approaches 0 plus x squared plus 128,000 divided by x squared. And you see that when x approaches 0, this term becomes 0, right? But the denominator in here also approaches 0, so this fraction becomes very, very large, right? So this is equal to positive infinity. And also we compute the limit on the other end, that is positive infinity, f of x, that is this expression, right? And when x approaches positive infinity, the denominator gets large, so this part becomes 0, but this square term also goes to infinity. So overall is also positive infinity. Okay, we see that the function approaches infinity at both ends, right? And at this point is a finite number, so you can see that the function has the local main at this point x equal to 40, right? And therefore we can now conclude that fx has a local and also global main at x equal to 40, right? And we also know that when x equal to 40, y is equal to 32,000 divided by x squared. That is from the beginning here, right? From the beginning here, divided by 40 squared, that is equal to 20. Okay, therefore the dimension of the box that minimize the amount of materials used, or base equal to 40, right, centimeter, and the height is equal to 20, so it's 40 times 40 times 20. Okay, that completes this question. Okay, you see that is also the same as the previous question. You have the target function, and then you compute a derivative, and then claim that this is the local main, right? And also a global main by checking the limits, just like the question 1b. Okay, so I believe that is very simple, question 3. Now let's move on to the last question, question 4. Now question 4, we have a book to contain 384 square centimeter of printed material per page, right? And this also need to have some margins for the 4 centimeter along the sides and 6 centimeter along the top. So what does that mean? That means the actual area of the image that must be printed out is here. So that is the area of the image, right? It does not specify the dimension of it, right? It could be skinny or it could be very flat. So that is up to the design. But what is fixed here is the margin. We must have the margins along the side, and that is equal to 4 centimeters. So that means you need to expand a bit here by 4 cm and also here by 4 cm, right, as well as here by 4 cm, right? That is along the side, okay? Also along the top, you're gonna expand this by 6 cm. So here is 6 cm, 6, okay. That means the actual size of the paper, or the amount of paper that is used, is actually this large rectangle here. Okay, so these are the yellow area are the margins. Okay, like that. The margins is here, and the inside is the image. Okay, so that is basically what it looks like. And our goal is to minimize, of course, the amount of paper, right? So we don't have to use that much paper. So now let's figure out our target function here. The target function, of course, is the area of this large rectangle. And now let's set this length of the image equal to x, and the height is equal to y. That is just for the purple rectangle here. So we know that the area of the image xy, it must be equal to 384. That is fixed, right? It cannot be changed. And we can now deduce that y is equal to 384 divided by x, right? And our target function is a of x equal to, that is the area of the yellow rectangle, right? So we're gonna have the height here is equal to 6 plus 6 plus y, right? 6 plus 6 plus y, and the length here, that is 4 plus 4 plus x, right? So the area is going to be equal to this 4 plus 4 plus x times 6 plus 6 plus y, okay, which is equal to x plus 8 times y plus 12. And we kind of expand this, so we have xy plus 12x plus 8y plus this 96, okay? And then plug this y into this expression so that we only have one variable, and then that gives us x times 384 x 12x plus 8 384 x plus 96. And this can be simplified to 12x plus 3072x plus 480. So that is our our target function. We also need to know the domain, right? So the domain depends on how large and how small x can be. And like in the previous question, right, the design is up to you. So you can make this image here very flat, so that x will be very large like this, right, and it's gonna be very short. Or you can make this rectangle very skinny and very tall, so x is very small. So you see that the range of x here can be as small as 0 and as large as infinity, just like in the previous question, right? So it's from 0 to infinity, right? And now to determine the min or max value, we need to take the derivative. That is equal to 12 minus 3072 divided by x squared, right? Just by using the parallel rule. And we let this equal to 0. And now we have 12 minus this equal to 0. And then we move that to the other side. So this is, or we can multiply s on both sides, x squared. So that we have 12x squared minus the 72 equal to 0. And then now 12x squared is equal to 3072, right? Now x is equal to 3072 divided by x divided by 12. And this is equal to 256, right? And now we have x equal to 16. Of course, we also have a negative 16, but that is not in our consideration because x cannot be negative. Okay, and also the domain here requires that x is greater than 0. So we only have this critical number, right? X equal to 16. Okay, and because it's the only critical number in this interval, so we just need to compute the limit when x approaches these two ends. So first 0 plus x approaches 0 plus 12x plus this 72x, right? This, we see that this guy is gonna approaches infinite 0, so that this fraction has a very small denominator, so this fraction becomes very large, right? So it approaches infinity, and this term approaches 0, right? This term does not change, and overall it will approach positive infinity, right? And for the other end, that is x approaches positive infinity, a of x, that is also this expression here. And in this case, we see that when the denominator gets very large, the fraction becomes very small, so this term is 0. But this term approaches infinity, so overall is also infinity. Okay, so from here, we know that AX has a global min at x equal to 16. Okay, this critical number give us the global min value. Okay, and now when x equal to 16, we have y that is equal to 384 divided by x, that is from the beginning here, right? This one. So divided by x divided by 16. That tells us 24. Okay, and therefore the dimension of the smallest page R is 16, that is x, right? And then we have to plus 4, right, in here, remember? X plus 8, right? And then y plus 12. Okay, so that is 16, that is our x. And then we need a plus 8, right? And then this is going to be centimeter by, that is y. Y is 24, right? 24 has to plus this 12. That is the margin, right? Centimeters. Okay. And that is equal to, 24 centimeter times 36 centimeters. Okay, so that is the dimension for the smallest possible page. It's a little bit more complicated than the previous question because the picture here takes some time for you to figure out, right? How the margins is put in here, and also figure out the area of this whole page, right? It has the length x plus a and y plus 12, like that. But overall, there's nothing more complicated, not more complicated than doing the derivative stuff. See that we just apply the closed interval method here, not closed interval method, the limit method here, right, to determine that this is a local mean and also a global mean. So it's also extremely similar to the previous questions. So I think that is all for this question, and then I will see if you guys have any questions. Any questions?